Hey guys, good morning. Happy Thursday. Back at it again. So you've noticed Cocoa Pie hasn't been in the picture. He said he quit. He said our math has nothing to do with doggy bones. And that's the only thing he cares about. Well, it's a dog's life. So Cocoa Pie, you're released. Okay, guys. Yesterday we worked on being able to solve. So we were just solving and calculating a two-step equation, and you had a two-step equation maze for homework. And I have the answers here. Let's see how you did. So take that out. Check it out. Did it lead you to the right path? I have uploaded the answers to this on our attachments for today. So if you want to check that out more closely, download or click on that PDF file and check out your work. Email me with any questions. Some of you have already emailed me with some questions. And what I'm doing is, for those of you that don't know, whatever question you have, I work it out on a piece of notebook paper, take a picture of it, write out the steps on the side, and I email it right back to you, and that has seemed to be helpful. So if you do have a question, don't hesitate to ask, okay? I am here to help you, and I know this is a little bit challenging, so let me know, okay? Do not suffer in silence if you're not getting something. All right. So as promised, after teaching you basic calculation, we always go into word problems. So today is a word problem day, which means that we're going to be connecting the knowledge that you learned yesterday of calculating a two-step equation, and then we're going to incorporate it today into some word problems, okay? First, I want to go over the format of a two-step equation, which yesterday we learned that the most popular type of two-step equation is actually a linear equation, which you will learn all about next year in your 7th grade accelerated class. You will have a whole unit on it. Okay, so I'm just going to briefly introduce it, but I'm going to show you how the different parts of the equation work when we relate it to a word problem so that you know what you have to look for. All right, so have you ever seen this equation? Y equals mx plus or minus b. It's actually called slope-intercept form, but it's really just a two-step equation. So let me throw some numbers in here so that it can make a little bit more sense. Yesterday, we worked on a problem like, let's see, actually, I'm just going to pull one from your maze. How about that? Okay, so if you look at the first problem where we started, 4x plus 10 equals negative 26. That would look like this. 4x plus 10, and in the work that we did yesterday, our totals were on the right side, but it can be on the left side. All right, so how does this relate to a word problem? I'll show you. Usually the number that falls in M it's always a coefficient, okay? And this section is always some kind of repeating value, okay? It's a repeating value or a repeating cost in relation to a word problem. So it's like they're charging you over and over again for something, okay? Then the position of the constant, the 10, which falls under the B, that is usually a one-time fee, or let me write that down. It's usually a one-time fee or a starting point, like a starting value, okay? So let's go ahead and I want you to refer to the one attachment that I have for today. I really just put one. It's going to serve as our notes and guided practice and independent practice. If you will look at number 1 on your two-step equation word problems, it's talking about Bennett. Okay, I have reprinted it here on the side. And I'm going to walk you through how you would pull the numbers for this two-step word problem, two-step equation word problem, and format it so that we can use our equation to solve whatever question they're asking us. Okay, so let's just read through. As we are reading through, I want you to spot two things. I want you to see if you can find a repeating value or repeating cost and a one-time fee or a starting value. Okay, so you're going to be looking for these two things. Now, we didn't talk about the number that y would be. Y is always going to be like a total cost. A total cost or a total value. Total value. So, all right. So let's go back to the word problem, and I want you to look for what might be the repeating value and what might be the one-time fee or the starting value. All right, it says Bennett and his friends decide to go bowling. The cost for the group is $15 for all the shoe rentals. So everybody in the group is going to get bowling shoes, and the only thing you have to pay is $15 for all the shoes. Plus $4 per game. The question is, how much is the total cost for 5 games? All right, so we have this group of kids. They're going bowling. They need bowling shoes, and then they have to pay for the games of bowling. So, which is the repeating value? Are we paying $15 multiple times for the shoes? Or are we paying $4 multiple times for each game? Which one of those is the repeating value? If you said that the $4 per game is the repeating value, that is correct, which means that your one-time fee is the $15 for the shoe rentals. So the $15 is going to be our one-time fee. Okay, so now let's construct an equation, a two-step equation, so that we can find the total cost for 5 games. So I'm going to leave my notes, but I'm going to erase these values. All right. So, question. Do we know what the total cost or the total value of the bowling is going to be? No, we don't. We're actually going to find that out. So I'm just going to put Y. The repeating value, we said, is going to be the $4 per game. So we're going to say, I'm going to go ahead and throw in a dollar sign in there. $4 per game. So in the traditional format, we use X, but I want to use G to represent game. You guys know I always like to use variables that match the word problem that we're working on, okay? So we're gonna be paying $4 times each game that we're gonna play, so that is our repeating cost, and our one-time fee is our $15 for the shoe rentals, okay? So now that we have set up our equation, now we can start to calculate what the total cost will be. All right, so I'm going to erase my repeating value so I can have some space and my other notes. Okay, so should I leave this G in there, or should I replace that G with something? Go back to your question and see if there's something in there that we can use, okay? Because we can't really solve an equation when we have two unknowns. We can solve it if we have one unknown, but we can't do it with two. Maybe when you get to higher levels of algebra. But at this point, we can only solve an equation if we have one variable. All right, so it says how much is the total cost for 5 games? I want to know how much it's going to cost for 5 games. So I hope that you're thinking that this G can be replaced. So underneath it, I'm going to write Y equals $4. I'm going to replace G with the 5 games that we want to figure out, plus our $15 shoe rental. Okay? Hopefully you can see right now that you can go ahead and calculate that the cost of the games here is going to be 4 times 5, that's $20, plus $15 for our shoes will equal our total cost. And once we add $20 for the games, $15 for the shoes, our total cost will be $35 to play 4 games with the shoe rental included. Okay? What do you think about that one? That's pretty good, huh? Okay, so you're going to always be looking for 2 things. You're going to look for your one-time fee or your one-time value or starting value. And there's always going to be a repeating cost or a repeating value. Something is going to be repeating, something is going to be just a one-time. So let's try number 2. So hopefully you're still on this sheet. We're going to go ahead and move on here. Go ahead and pause me if you need to copy down any of that work so that you can have it to refer to later. All right. Number 2. We are looking for 2 things, repeating and a one-time fee or value. A plane loses altitude at the rate of 20 meters per second. So what's happening to the airplane? If it's losing altitude, that means the plane is descending, it's coming down, like getting ready to land, for example. So a plane loses altitude at the rate of 20 meters per second. So what's happening every second? The plane is descending 20 meters every second, every second, every second. All right. It begins with an altitude of 8,500 meters. Did you spot the repeating value? Did you spot the starting value? So the 20 meters per second, 20 meters, all of this, that is going to be our repeating value. And here's something important to pay attention to. This is something you learned back in Unit 7 when we did our word sort. This loses altitude is going to be quite important because it tells us something about the sign of that 20. All right, so we got our repeating value. What's the starting value? The starting value is that we're looking at the plane once it's at 8,500 meters. We're starting there, and then it's just going to decrease in altitude every time. So our one time, I'm going to put an O-O-T for one time value or starting value. All right, so maybe we can go ahead and just start setting up. So I'm going to say y equals, and my repeating value is that it loses 20 meters per second. So because it's losing 20 meters per second, I'm going to say negative 20 times m for meters, okay? Or actually, I think I'm going to change it. I like S better because it's going to lose 20 meters for what? For every second. So I'm going to go with S. And it begins with an altitude of 8,500 meters. So is that a positive 8,500 meters or a negative 8,500 meters? So because you're above ground, you're in the sky, on a vertical number line, that's going to be a positive 8,500. Okay? Now, do you spot a problem? The problem is we have a variable here and a variable here. We have to replace one of them. So let's keep reading. What is the altitude of the plane after 1 minute? What is the altitude of the plane after 1 minute? Oh, wait, hold up. This is after 1 minute, but this losing 20 meters is for every second. So I have to do a little extra math here. Can you think about what we have to do? We have to convert. That's right. We have to convert the 1 minute to seconds. So how many seconds in a minute? Hopefully you're thinking, oh, that's 60 seconds in 1 minute. So now we can take the S out. We're going to replace it. So we're going to say y equals negative 20. We're going to replace our seconds with a 1 or with a 60. We're going to replace it with a 60 because it's 60 seconds. Okay? Plus 8,500. Y equals. All right, here we go. Use order of operations. We have multiplication going on over here, and we have addition. Which one comes first in PEMDAS? So you're going to multiply first. Okay. 20 times 60 is 1,200. However, you have a negative times a positive, which means that 1,200 is negative. Remember, you're losing altitude, okay? Write down what you have left, plus 8,500. Y equals, we are about to arrive at the descending altitude. So you can see that we have a negative and a positive. So they have different signs. So if they have different signs, we're going to go different signs, subtract, keep the sign of the higher number, then you'll be exact. So subtract them. Go ahead and calculate that. You should get 7,300. And my question to you is that 7,300 negative or is it positive? It should be positive. So I'm going to leave it like that. Or let's answer the question. What is the altitude of the plane after 1 minute? 7,300 meters is the altitude after 1 minute. All right. Questions so far? Email me if you have any, okay? All right, we're going to do our last problem. Now, on the last problem, we're going to work on number 3 on the same sheet that we're working on, okay? Number 3, we have to work backwards a little bit, so watch this. Again, we're still going to need some kind of repeating value and a starting value, okay? Paul rented a bike from Callie's Bikes. That's the name of a bike company. It costs $13. Ooh, okay. Plus $8 per hour. Per hour. If Paul paid $45, then he rented the bike for how many hours? Oh, this was a little different. All right, so what do we know? Did you find a repeating value first? Okay, let's do that. Our repeating value is going to be $8 per hour because you might rent the bike for a half hour. So then you would use a fraction. You might rent the bike for 2 hours if you're in a little beach town and you want to ride around and kind of check out the sights and check out the town. You might want to have it for the whole day. You might rent it for 5 or 6 hours. So those $8 you're going to pay for every hour that you have the bike, okay? So $8 per hour, that is a repeating value. I'm going to label it R. Okay, now they're charging you something else. Paul rented a bike from Callie's Bikes. It costs $13 plus $8 per hour. So that $13 right here, that's going to be a one-time fee. I'm labeling it OT. Usually a rental company will charge you a one-time fee for like maintenance purposes, right? The tires need to be changed, the bike needs to be maintained. So they usually charge you per hour plus another kind of fee. All right, continue reading. If Paul paid $45, then he rented the bike for how many hours? This $45, that's a total that he paid, right? I'm going to label that total. Okay, now let's recall the formatting that I had taught you earlier. Y, or the cost, is always Y equals, then you have a repeat, and then you have a plus or minus, like a starting value or a one-time fee. One-time value. So let's plug in our numbers. Do we have the cost? Actually, I don't even need that. Our cost is that Paul paid $45. The repeating value is $8 per hour. So I'm going to say $8 times H per hour. Plus, he has to pay a $13 fee. Plus 13. Do you notice something about this? This is like one of the equations that I taught you yesterday. So at this point, what we're trying to do is we're trying to find out how many hours he rented the bike if he paid a total of $45. So I'm going to go ahead and put my equation line and start working. So we have to move the constant first, which the constant here would be 13. So I'm going to subtract 13 from both sides. Those cancel. And let's see, 5 minus 3, that's 2. 4 minus 1, that is 3. It's money equals my $8 per hour. Oh, that's looking pretty good. Now I have a one-step equation. What's happening to the variable? It's being multiplied by 8. So if it's being multiplied by 8, I have to divide by 8, cancel, divide by 8. That means that the hours that he rented that bike for had to have been 32 divided by 8 is 4. So now we can answer the question. For how many hours did he rent the bike? Paul rented the bike for 4 hours. Okay. So I'm gonna leave you to work now. And what I want you to do for every one of these problems is, well, you're going to read through the problem, pick out your values, write an equation, use that equation to solve for the question that is being asked. Okay? This is a total of 10 problems, but we've already solved 3, so you have 7 to work on. Okay? We will check the answers to this tomorrow at the beginning of class. And also please make sure you're doing your Mobimax because I am checking that. All right? Bye guys.